class. I hope you had a good first day yesterday. Here are the practice problems that I assigned yesterday on thermochemical equations. And the first one that says consider the following thermochemical reaction for kerosene. And so the reaction looks like this. You all have it in front of you, I'm sure. C12H26 plus 37O2 yields 24 CO2 plus 26 H2O, and then the energy that's released here is 15,026 kilojoules. So you can see that the energy terms on the product side, meaning that it's going to be an exothermic reaction with a delta H of negative 15,026 kilojoules. But being on the product side of the equation tells us that. So it says when 21.3 grams of carbon dioxide are made, how much heat is released? So here's where we use our stoichiometry. We're going to take 21.3 grams of CO2. Always start out with what you're given in the problem. Then you're going to set up the old familiar picket fence, and we're going to say that there are 44 grams of CO2 in every 1 mole of CO2. Right, that's just our molar mass of carbon dioxide. And then from our balanced thermochemical equation, we'll use our ratio, which is 24 mole of CO2 for every 15,026 kilojoules of energy. All right, and so then we'll just say equals, and now we'll plug the numbers into the calculator, and it's 21.3 divided by 44 times 15,026 divided by 24. And we get an answer of 303.08 kilojoules. Okay, so that's it for number one. It tells us that if 21.3 grams of CO2 are produced, then that's how much energy we'll get, the 303.08 kilojoules. Right, so that's part A. Let's look at part B. Part B, it says, if 500 kilojoules of heat are released, how many grams of the kerosene, C12H26, must have been consumed, or another word for saying used up. Okay, so now again we start out with what we are given, which is our 500 kilojoules of energy. And so what we know is that from our balanced equation that there's 15,026 kilojoules for every 2 moles of C12H26. Okay, and then I'm just going to have to do the molar mass. 1 mole of C12H26, and then I just need the molar mass of the C12H26. That was a big 6. Okay. Oh, this is where I wish I had some help on coming up with my molar masses. 12 times 12, which is 144 plus 26 for the hydrogens. So I came out with about 170. So now I'm all set up to do the calculation, and I'll do 500 times 2 divide by 15,026 times 170, and I'll get 11.31 grams of the C12H26. So what that says is that in order for me to get 11.31 grams, I would need 500 kilojoules of energy. So I hope that's helpful for number 1.